In today's tutorial, we're going to implement the basic moving controls, and it's pretty simple. First thing we need to do is add our character components. So we're going to start with our velocity, and then we're going to add accumulate inputs. We also have the drive, which brings in a bunch of functions that we're going to use throughout our program. Note that public allows us to access it outside our file. It's very important, as you'll get errors if you don't include public. VEC3 is us declaring a three-dimensional vector. So what that means is a vector that has three components in a 3D space. That means that if you're graphing it, you have an X, Y, and a Z. If you're familiar with Minecraft, that might help you understand it a little bit. Just imagine that you have a dot from 0, 0, 0, and then you connect it to whatever position that you're going to. And that's our three-dimensional vector. And we're also gonna define a component called movement, which is gonna be a two-dimensional vector because our input WASD is only in two dimensions, and that will define our components. Okay, now let's add our components to our entity. So to do that, we just need to type in accumulate input. And then we're going to do default, so it just creates a default 0, 0, 0 vector. And then we're going to do the same thing for velocity. To get a good understanding of what we did here is we basically added our members to our class. If you think in terms of C++, the next thing we need to take a look at is our transform. If you notice, our transform only changes the position of our object. Transform actually has three components, such as the transform, and then you also have rotation and scale. These are very important to know that transform can do, as you will often be using it in your video games. So first we need to start by creating a three-dimensional vector, and this will be 1.5 meters off the zero base at the origin. And then you have your rotation. We're just gonna set this rotation to a default value, as we don't have any interest in rotating this object yet, but you might in the future. Right now we're just going to have default rotation, and then we're going to do scale. So we're going to make our object a little bit bigger. So we're going to create our three-dimensional vector once again, but instead of typing in, we're just going to use splat. What splat does is it fills each component of our three-dimensional vector with the same number. Okay, the next thing we're going to do is we're going to take the user inputs and we're going to change the position of the player. So to get a good understanding before we get into there, we need to define our axis. So in Bevy, when we go towards and away from you, that is the z-axis. And then when you move to the left and the right, that's the x-axis. And the y-axis is going to be up and down. This is going to be really useful to avoid confusion. Okay, let's now define our function that accumulates the user inputs and then turns them into translations. So we're going to call the file called accumulate_input, and then we're going to rs. And to start off with, we need to include our Bevy. Bevy provides all our functions, and it's the game engine, so we gotta have it in here. So now we got defined. Let's include our player function, and this is going to be kind of like the Bevy library as before, but this time we're going to only include two resources, and this is going to be velocity, and then we're going to have accumulate input. These are the two guys we're going to be working with, and then we also need to make the plugin for our function for accumulate. Notice that we have update on our add systems. This allows it to run continuously through our functions. This update is going to be based off how many frames they go by. Not ideal, but that's just what we're going to have to deal with. And now let's quickly define our function. So we're going to call it a spawn accumulate input. And then we're going to open, close, open, close. And now let's get started with the rest. So Bevy has access to your key inputs. So as a resource they provide that allows you to access it in your program is called keyboard and then input. And then we're going to do res, which allows you to read whatever Bevy resource that you have. And you have button, input, key, code. So this allows you to extract the data that Bevy has from your key input. So it's basically a key logger. And then now we're going to do key. And then, okay, now we're going to do our player. And this is where we bring in our resources, our components that we defined. So we're going to do mute, which allows us to change them. And then input. And let's do our velocity. And then transform. As you notice, we do add transform here, but because it's not like a component as we had to define separately, we don't actually have to bring it in as before, as it's implicitly brought over from player at the beginning of. So now that we have this is everything we need in terms of our, I guess, parameters. That's what it'd be called. Let's define our variables, because we do need to put these into temporary variables. So we have input. This is going to store accumulate input, and then we got velocity. This is going to store velocity vector, and then movement. Movement's going to store the actual position of our guy from transform, and we're just going to call this a v. Notice that it doesn't rely on the order of things because you're getting it directly from what you define here. But notice that this and this do need to be in the same order when it comes to how you define them. So now that we know that, we do player into, and behind the scenes, this function into inner is a query that looks for these three guys from our player, and then it loads in them one by one. So order does matter right here. So make sure that these are not make sure that they're in the right order. So now that we got that, we have our variables are loaded up. Now we need to define our input. So we need to set this to 0, because this is going to be the function that extracts the player movement. Every time we want to go through it, we want to set it to 0, because if we didn't, let's say the player enters W once, the character will just keep moving and it won't stop. So we need to set it back to 0 after they click it. So to do that, we're actually defining a vector, a 2D vector, and we're setting it to 0. So that means all the components are 0. Notice that we're accessing a element inside our struct from accumulate input. And now that we have that, we get to check for our inputs. So we're going to do if keyboard input pressed, and then we're going to use our Bevy resource, our behind the scenes keylogger, and then we're going to check for the W key. Now if it's pressed, we want to do input.movement.w is +10, so we're adding 1 to this. And if you notice, this is the y-axis, right? Is it up? No, that's not correct, because our accumulate input is only back, forth, left, right. So it's a 2-dimension plane. We're going to get to know what this means in a moment here. But let's first copy and paste this so we can speed things up. And what we're going to have to do is we're going to take these 2D inputs, and then we're going to have to map them onto a 3-dimensional plane. It's a very simple thing to do, and I'll show you to do in a second here. So now that we copy and paste this, let's do it for each key that we need. So W is forward, so back is S, right? So let's define our S right here, and this is going to be in the same direction. Whatever Y and X is for a 2D plane, it really doesn't matter as long as it maps onto our 3-dimensional plane as intended. So this will be back, and then A is going to be left, and D is going to be right. So left is going to be negative, because why not? And then we need to change this to X, and this is going to be for A, and then we got our D keypad, Again, this is our two-dimensional plane, and when we go right on our 2D plane, we want it to be positive. So now that we can check for when these are keys are pressed and we accumulate them onto our 2D plane, let's remap these into into our velocity vector so that we can actually start moving our guy. So to do that, we're going to define a 3D dimensional vector called input 3D equals vec3, and let's open this up. So you can define a three-dimensional plane and their inputs by each column, whatever. I'm lost for words, but you know what I mean, your x, y, and z. So we're going to do our x's for x. Remember, on our three-dimensional plane, this is x, this is z, this is y. So y is going to be 0 because we're not moving up. And then we have our z. So z is going to be the inverse of our y inputs, because in Bevy, for whatever reason, it's just flipped around. So we have to just put a negative sign in front of that. Alright, I guess it depends how you interpret it. If you made this negative that positive on our 2D plane, then you wouldn't need it. But it's really how you what perspective you put this in. So now that we have this, let's initialize our velocity vector now. So to do that, from our deviations that we put above our components, we can just assign it. So we're going to put input 3D, and then we're going to multiply it by this constant speed. The reason why we want this speed, because we can change this. Let's say if you wanted to add like a speed bonus in your game, as soon as you go, you want to change some variable that can increase your speed. And then also notice that velocity is just a variable. We want to do .0 so we can access that vector that's inside it as a member. Now let's define our speed, because if you remember, we haven't defined our speed yet. For now, we're just gonna make this a constant at the top, so we can get the idea like why does this exist. It's so we can make our character go faster or slower. And because this is by frames, there's a lot of frames that happen. We need to make this a small value. Later on, 1.5, once like you're actually going by seconds instead of frames, it's actually like about the speed of somebody walking. But because we're by frames, we need a small number, or else our cube is just gonna teleport almost. And now that we have our velocity, we need to map this to or not map this, we just need to assign this to our translation. So we're gonna do movement v dot translation. Notice that we're accessing the translation component of our translation member of our player. And then we add our plus our velocity. And because this is position and our velocity is zeroed at some point in time, we don't have to zero the transition. Because you don't want to do that, because then your guy's going to go here and then he's going to teleport back. Before we move on and even try to test our program, currently our code that checks for key inputs doesn't even run, because we need to include this in our Bevy app. Our Bevy app is what runs our actual functions that we want to run. So to do that, we need to open our main RS. This is kind of like your header file if you think about C++. It's very, you can think of it like that. It's not exactly the same, but if you learn C++ from college or online, it makes more sense if you think of it in that way. So we're going to do mod accumulate input, and then we're going to accumulate underscore input, and then our plugin we define, so accumulate input plugin, close that off. And then we also need to add plugins, because the add plugins is actually where the game engine executes our plugins. So accumulate input plugin. And then let's see if we have any runtime error. Compile errors. So we're gonna do cargo run. And there's a couple issues here. as you can see, if we go back to this one, accumulate input, notice how this I is a capital. We define that with a lowercase I. And then also accumulate input is probably misspelled too. So let's open it up and fix that here. So once we open this up, you see accumulate input that has a lowercase I. And then once we come down here, this should also have a lowercase I. Let's see if that fixes it. So we're gonna use cargo build and see what else we got. So accumulate input rs. We also need a semicolon at line 44 or something like that. So let's go down there. Oh yeah, so we gotta close this off once we create our new variable. And let's see if it compiles. And then the last thing is accumulate input in player rs. It says that there's a similar one, accumulated input. So let's open up our player rs. We actually don't want accumulated, we want to accumulate inputs. So to fix that misspell, we're just going to go right here, delete that, and delete that. And now it should compile. Accumulate input, and see how it's a capital I as before. So we're going to go back to player I. I'm going to go back into here and change this to a lowercase I and this to a lowercase I. So maybe I wanted uppercase, but it's just the syntax, so it's okay. And then it says cannot find it in scope. Accumulated input. Accumulated input. And then we just need to get rid of that D right here. And it should find it now. Cargo build. And yep, everything's compiled. There's a couple syntax errors. So let's run it and we'll see our project come to life. And here we go. We can see our object. We can move left, right. We can go diagonal. And we can come right back. And that's it for today.